disruptions. So when I think, have you seen the video the day before, right? Hello? Hello? Am I audible?
Yes, sir.
Yeah. So there, I think you have seen that, you know, the dough is made. It is, what to say, pulled by a hook. And the reading at which the dough gets cut or the string gets cut is noted. The dough is again remade. It is made as a dough and then it is done. So why is it done is that the resistance in spite of repeated disruptions of the cell structure, that is the ability of the gluten network to form quickly in spite of the disruptions, is what is measured. And again, it is an indicator of the dough strength. Why uh, is it important? In the case of bread manufacture, the most important thing is the one is the gluten structure and the strength. Now, in the case of farinograph, you see the maximum, what to say, the ability to hold on, the ability to maintain the structure, and the point at which the, what to say, the dough crumbles. So in that case, on constant, what to say, disruption or constant stirring or agitation, what happens to the dough is what is given in the as a reading in the farinograph. In the case of extensograph, the ability to reform after repeated disruptions is what is given. Hope I think you are able to make the difference, right? Hello? Hello?
Yes, sir.
So that is the difference between extensograph reading and the farinograph. Farinograph is you put the dough, try to, what to say, agitate it, whatever the maximum, what to say, dough strength available, and the time at which the dough crumbles is what is given. Here it is the repeated disturbances and the ability to manage it is what is given in this case. So resistance to extension is a measure of the dough strength. The higher resistance to extension requires more force to stretch the dough, and extensibility indicates the amount of elasticity of the dough. Fine. So extensograph works by taking, okay, I think this we have already seen. So the testing regime is repeated after about 1.5 and 3 hours. So unlike a farinograph where it is a one run, a single run, here the dough is repeatedly stretched and the strength checked. So these are the other details. A 300-gram flour sample is taken with normally 1% sodium chloride solution. The dough is rested for 5 minutes for making up the structure. Then it is, then 150 grams of the prepared dough is placed. And I think you have already seen. So here what is important is the height. Okay. So this height in the case of strong flour will be much more. I think you can note the difference. Okay. It is much higher here. So this shows that the, what to say, dough is comparatively strong. So now I have a weak gluten flour, you have a strong gluten flour, and this is what is given. No, the interpretation is the maximum height and this thing. Both of these things matter. So resistance is defined as the height 5 centimeter down the chart, while the maximum is the maximum height reached. Resistance is here, and this is the maximum that is available. Okay. Extensibility is the length that the dough was stretched before it broke. So this is the thing. So this will give. So the area under the curve gives you the total time to which, what to say, the dough can withstand the disturbances, or you can also call resistance to extension. Okay. So the ratio of extensibility to to resistance and the ratio of extensibility to maximum are calculated. So bread flours are resistant and have some extensibility. So In this case, what it mean? Resistance is this one. Extensibility is this. So at the end of the day, a good flour for bread. Remember, I think I already told you all the tests till now are more focused on bread rather than on cakes and biscuits, because cakes and biscuits do not actually require high gluten strength or extensibility, etc. You are fine with whatever the required what to say strength. And one more thing, again, you will see it later, that the gluten content, or the in the case of bread, the structure is more because of gluten. Whereas the cakes of in the case of cakes and bread, there are other factors come into play apart from the dough strength. In fact, there is no need for a dough in the case of a cake. You are not supposed to form a dough. The details we'll see later. Okay. Um, okay, fine. Now, extensograph curve. These are the various testing. This is the maximum. Okay, resistance is 5 centimeter down. The maximum is what is the resistance. So everything is given. It is in Brabander units. You can go through this. Okay. All these things you can go through. Fine. Now, when you consider the comparison of arenograph and extensograph, the resistance is 300 in the case of an extensograph. Okay. And the area under the curve is around 170 for a top quality bread flour. And between 250 to 350 is a baker grade bread flour. Now, what is the difference between top quality bread flour and baker's grade bread flour? Again, we'll see later that in the case of a baker's grade bread flour, whatever we are doing as of now. Again, I think I remember I told earlier in the class also, though these tests are being followed now, whatever the procedures that are followed is more on the, maybe these were all followed and was considered significant maybe 10 or 20 years before, because in those days we had strong weak flours. We had also categorized strong flours can only be used for bread, and can be used for bread as also biscuits or cakes, whereas in the case of a weak flour it cannot be used for bread, etc. But over this period of 20 to 30 years, due to advancements in technology, okay, now we have even gluten raw. So normally what they do is that if it is a weak flour, then gluten is added to add to the strength, thereby then I can make bread. So gone are the days when we were categorizing flour as strong and weak. Strong flour only for bread, weak flour cannot be used for bread, etc., etc. Because during those times, some 20 years before, etc., we never had this technology of gluten addition or the concept of gluten addition to flour. But nowadays, gluten is added to flour to make up for the, what to say, uh, whatever the deficiency that dough is, the dough has. Okay, fine. So that is the thing. So in the case of a baker's grade bread flour, we have gluten added. We have also have some of the other enzymes being added. Now, why is this important? Um, some 20 or 30 years before, okay, we never had the concept of whole wheat bread or multigrain bread or high fiber bread. What is multigrain bread? Can anybody tell? What is a multigrain bread? Quick. What is the difference between a multigrain bread, whole wheat bread, and a high fiber bread? I think whatever you can, you can answer. Hello? Hello? Quick. What is
Sorry,
normal bread? What
multigrain
is,
other than
huh?
with other grains are used.
Which are the grains?
We can use millet.
Okay,
We can
so
use
millets or other things. Okay, then high fiber is any other person. Hello, quick. See, entire first unit will be for the first internals. Now it is up to you to make me complete the portion or try to delay or derail by all these tactics. Understood? So it's up to you, totally up to you, because a certain level of response is expected. Or I think I'll start calling names, and if you are not answering, maybe I have to remove you from the class. Am I right? Hello. Okay. No, that is fine. What about high fiber bread? Now we have whole wheat bread, what to say, multi-grain bread, and high fiber bread. Now, what is the difference normally? What is a high fiber bread? Quick, should I call name? Okay, Delicia. Hello. See, if you're not answering, I'll be removing you from the class. Simple, very, very simple. What to say? Tactic, right? Hello. Am I audible? Hello.
Yes, sir.
Okay. Somnath, are you there?
Yes, sir, I'm there, sir.
Yeah, put on your camera. I'm not, you are not that audible, no? Tell me. So, what is a high fiber bread? Hello. Put on your camera. Yeah, tell me. Eh? No, no, tell me. What is a high fiber bread? Hello.
Sir, high fiber made is made of
Yeah.
the whole wheat. White wheat.
They are not audible.
Sir? Oh, hello.
Rahil. Hello. 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 Okay. I think you are giving me good reasons for removing you from the class. Okay. Who else? Gokul.
Yes, sir.
Yeah. What is a high fiber bread?
The bread which are made from cereals which have high fibers.
What do you mean by fiber? Put on the camera, no? Put on the camera. Yeah. What are the fibers? Example. Can you share some example? Hello.
The fiber which contain grains, sir.
Grain is different, huh? Grain is what you call as grains is include something like your millet, you know, even some of the legumes and other things. That is a multi-grain bread. High fiber
Yes.
bread is okay. Anthony Kurian. Hello, Anthony Kurian. Are you there?
Yes, sir.
Yeah. Tell me. So put on your camera. Yeah. Yes. Okay. So The differences is what is your baker's grade bread flour. Of course, soft wheat flour is normally used for cakes and biscuits. Okay. Now we'll go back to the other thing, which is a alveograph. Now, alveo means air. I think you know that. So, alveograph is a instrument which measures the maximum air incorporation possible by the dough. So the maximum air that can be maintained without any disruption in the cell structure is what is given by an alveograph. So flour water dough is made under standardized conditions. Same way here, everywhere you add normally 1% sodium chloride for making the dough. So the dough is in what basically is happening in the case, like in simple terms, what is done is that a dough is prepared, okay, and you make a thin sheet out of it, something like what you do for your chapati, etc. And this is kept on, and air is blown through this uh, flat sheet. Now, when air is blown, what will happen? The dough will start bulging like a balloon. Same thing as what you do in a balloon. It will go on expanding, and at a particular stage, it will burst. So the maximum air that can be withstood, air pressure that can be withstood by the dough, okay, is noted, and this is an indicator of how far how far the bread dough can stretch. Again, it is an indication of the gluten strength and the amount of gluten. So the alveograph records the pressure variation with time. What are the things? The maximum pressure that can be withstood, the time the bubble took to burst, and the area under the curve. Now, area under the curve will give you the maximum, strength of the dough. Now, if you will shortly see the video of it. So, P is a maximum pressure, L is the time taken for the bubble to burst. Now, what does it mean? This is the pressure. In the y-axis, you have pressure. L is the length. So, when you consider, in your case of a high fiber, high resistant, now what are all the, what to say? Um, just a minute. Let me see. Okay. Fine. Now, when you consider, see, when this is pressure and this is length, fine. Now, in this case, what is done? You can have things like, going for a long time and then breaking. The other thing can be something like it can withstand a high pressure, but then it immediately falls down. The third variation can be like, it cannot withstand and it goes like this. Now, in this case, the first one is a strong flour. The second one is what? It can withstand, it can withstand the air, but but not for a longer time. The third one is the weak flour. So accordingly, then you categorize the flour based on this is the pressure and this is the time or length. So in both things we categorize it. Okay. So fine. So accordingly, then the P by L ratio, we have a high P and a high L. That is the maximum pressure, maximum time is a strong weak flour. And here the P by L, it should be 0.5 to 0.9. What does it mean by that? The dough, when it is close to 1, it means that P equal to L. Am I right? Right? When P by L equal to 1, it means that P equal to L. Am I right?
Yes, sir.
So what it means, the dough can withstand a maximum pressure for almost the same period of time. So this is normally used for bread purpose. So the alveograph reading is greater than 200. Now, some of these readings you are supposed to memorize or note. So the National Association of British and Irish Millers have classified based on the P by L and the alveograph reading. So the first grade is one where the P by L is 0.5 by 0.9. Now this is the maximum possible. Now what can be the other thing? The length is, sorry, okay, here. What are the things? Now the second variety is 0.4 to 0.8, slightly less, okay. And the alveograph reading is 170 to 310. This is the second thing, which has again a good bread making potential. The third one, okay, is 0.2 to 0.4. So you have up to 1, then around till 0.8 or something. The third one is around 0.2 to 0.4, which is a bread or a dough flour, which is suitable for biscuits. And the alveograph rating is 70 to 100. So if you consider, see here, the maximum is greater than 200 is for bread. This is the grade 1. Grade 2 is somewhere around 170. Third one is less than 300. And the fourth one is a inelastic dough, which is fit for animal purpose. Now, how do I again categorize these things? When you're doing the milling process, I get a range of byproducts. I get my flour, I get also the high fiber and other things. Now, obviously, one with a high fiber cannot be fiber, or that is a bran part of it, will not have much of the extension. So this is used earlier, they consider it as useful for animals, but now again I think you have your high fiber and things like that. Okay, so this table or this thing is very important when you consider the characteristics of the dough or the characteristics alveograph reading that is fit for what to say, that is fit for the preparation of bread. Okay. And amylograph, basically, as the name suggests, is about the starch content, the behavior of starch in the case of wheat flour. So normally, in the case of here, what happens? A slurry is made. In the case of an alveograph, in the case of an extensograph, a dough is made. What is the difference between a dough and a slurry? Adil? Hello.
Yes, sir.
So, what is the difference between a dough and a slurry? Yes. Hello.
Sir, dough means it is mixed with flour and water, sir.
Okay. Slurry is? What is a slurry? Yes. Any other person? Who else is there? Adrija.
Yes, sir.
Yeah. So, what is a slurry and what is a dough? What is the difference actually?
Slurry is a liquid with suspended particles of solid
Okay.
at the
So,
bottom.
yeah. When
Yeah.
the more the amount of what, when are going to add flour to water, you call it as a slurry. And when you are adding water to flour, it is a dough. Hope you may know that a difference. So a dough is much more thicker. Slurry is something like a liquid with suspension. Okay. So basically, in the case of an amylograph, it finds out the starch gelatinization and the relative amount of starch content of that particular type of flour. Okay. So basically what happens, same way as starch gelatinization, there is an increase in viscosity. Remember, a similar thing you have done for your Hagberg Falling number. It's almost similar. Okay. So the heating rate is controlled at 1.11 degrees centigrade, 1.5 degrees centigrade per minute. So there's slow heating, which is similar to what is observed during the baking process. So basically it is something like 65 grams of flour and 450 ml of water. In the earlier case, if you are making a dough, you will take, the amount of water will be comparatively less. Okay, so basically what is done, similar to what is observed in the case of a Hagberg Falling number, you have a disc, you have the bowl which is rotating, and in the bowl, you have sensors which measures the resistance to the movement of the slurry. So as the temperature increases, starch gelatinizes. As a result, then there will be an increase in viscosity. Okay. So, so this is the thing. So peak viscosity, the gelatin, the onset is what is called as gelatinization temperature. Now, let us see. Just a minute. We can have videos of alleograph and amylograph so that you are able to understand it better. Okay. Okay, fine. You're able to see? Hello?
Yes, sir. Yes.
Are you able to see?
Yes, sir.
Okay.
It is also cheaper than red flour because it usually has low proteins. So can you substitute all-purpose flour with red flour? I would highly advise against this. You may get away with it with small 10-pound dough batches, but once you're at the industrial scale, this substitution will wreak havoc on your mixer, your sheeter, depositor, and process as a whole. So it's not worth saving the money. As for the LVO graph, you will see an increase in elasticity index around 60 to 60 due to the increase in protein strength as compared to the all-purpose flour, which is around 45. Many years ago, high ash flour was not desired. In some countries like Japan, low ash flours, as low as 0.1%, are still sought after to make soft, white, fluffy bread that tastes like cotton candy. These days, the artisan bread trend has pushed the ash content to over 0.6%. Why? Because you can get away with an off-color low flour artisan bread instead as well. To learn more about what goes into the ash content, go to this page. In milling, as you grind closer and closer to the bread, or choose to have higher extraction flour, your ash content is going to increase. So as ash comes from the full mills in bread, that is going to increase as well. That's the future. So you ask, isn't that beneficial? Yes, it is. I would love to see the industry move towards higher ash flours because this would mean that the flour has more nutrients. What would this do to the quality of the flour? Well, if you go to about 0.65%, about a inch high, you may see a slight difference in color and maybe an increase in absorption. We'll also see an increase in your protein quantity, but that doesn't necessarily mean your flour would increase. Making quality of high ash content flour is worse than lower ash content flour and can cause lower quality products. Depending on what product you have, if you're a smaller scale bakery, you may be able to navigate this by giving it more fermentation time to improve the gluten integration and functionality. However, if you're an industrial bakery, the limitation of your process may not cater to increased fermentation time, and you might need more milk conditioners like SSL, data to prevent the detrimental effect on. In terms of the LVO graph, using constant hydration, dough faded, resulting in a higher tenacity and a lower extensibility. The effect of high ash on flour quality can be seen clearly on the LVO graph is a cool tool that blows up a dough and records its properties before it bursts and deflates. It is used to access the baking performance of flour in the production of bread, noodles, tortillas, and so on. To learn more about the LVO graph, visit this page. The LVO graph curve, which records the action of blowing out the bubble and bursting it, shows values that indicates elasticity, strength, tenacity, and extensibility. Not only is it a really effective tool to measure flour quality, it is also an official AACC, ICC, and ISO method as well. Understanding this tool will help you keep a closer eye on the quality of your flour and help you understand the variability between batches and in between the seasons of wheat harvests. If you're considering a purchase of an LVO graph and you've heard myths about it, here's my friend Arnaud to clear up some myths around LVO graph.
question, yes, I understood that because I heard that many times. And basically, the people are referring to the fact that the aircraft is using constant hydration, the protocol versus other devices which are using adapted hydration. In constant hydration, we always give both carbon the same amount of water, whereas adapted hydration, the water addition is adapted to the flow voltage. The question is, because of that, does that make a limitation for the algorithm? And here the question is clearly no. We can use the algorithm for any kind of process, and even we can use it on turbo with the constant hydration. And for this, we have three evidences. The first one is that we have thousands of users which are using the algorithm for more than 100 years. So they can't be wrong if they are using that in their routine, if they are using that for blending the flowers, looking at additive enzymes effect, even publications on this. So it means that we can use this adapted hydration anywhere. Then the second thing is that people say constant hydration is not representative of maker. What is representative? Because what is good for a maker doing bread is not good for someone doing gelato or someone doing noodle. Water absorption is not the same. So even if we adapt the water absorption, we are going to have a consensus on the level of hydration, which will be good maybe for some users, but not necessarily good for others. Even that is not a definitive solution. The third point is that the adapted hydration protocol exists since more than 20 years. So it's here. It's available. You can use it. And the good news is that this protocol is not the standardized method from the ICC with the number 188. The conclusion of that is that either you want to use it at constant hydration or adapted hydration, there is absolutely no real reason to limit algorithm to something. And this question often comes with the second thing that the algorithm should not be that precise because we have a lot of endings and we are using oil, and oil is certainly influencing the results. Okay, let's face the reality. And for that, we have two things to look at. First one should be to look at international standards. And in the international standard, you have precision methods. So you can refer to. And the second thing is to look at proficiency testing schemes like the EPA or AACC check sample. If you look at this circuit, you will have an idea of what is the variation when testing the same sample in different groups. If you look at that and you refer to standard method, you will see that the algorithm reproducibility is between 4 to 10% depending on the unit. Now, if you compare that with other tools which are famous in the industry, you are going to find 25 to 35%, which means that जिन्हें लगता है कि पढ़ाई की प्रोग्रेस इस साल रुक गई है।
My name is Lena Bosquebian. I am Product and Application Specialist for Chopin Technology. Today we will see how to run a test using an alveolab, a device from Chopin brand for measuring the rheological characteristics of a couple of dough during deformation. The alveolab is always composed of two inseparable parts, the kneading machine for dough sample preparation and the alveograph itself, where the dough patty is deformed into a bubble until it ruptures. Additionally, the alveolab comes with all the accessories necessary to manage the dough: the extrusion plate, the steel roller, the cutter, the laminating plate, the resting plates, a knife and a spatula, and a dropper for the oil. It also includes a filling hopper, a brush, and a mini PC, which is a central unit dedicated to run the alveolab. Before pouring up the device, fill the water tank with salted water at 2.5% if necessary. Turn on the device thanks to the power button. The initialization will last 5 minutes. Finally, turn on the mini PC and the alveolab will be ready to run. In order to run a test, you need to configure the test within the software. Click on Test, then on Start Test. Select your protocol. In this case, I will be demonstrating the standard test at constant hydration. Enter the name of the test, select a partner and a product, and indicate the water content of the flour. Click on Next to see a summary of the configuration of your tests. Click on Start Test and follow the indications given by the software. Weighs 250 grams of flour to an accuracy of plus or minus 0.5 gram. Place the hopper on top of the mixing bowl and gradually insert the flour into the mixing bowl. When all the parameters have reached their reference values, send the instruction of the test to the device and start the water dosage. Once this dosage has been carried out by the device, position the water injection nozzle on the tank. Start the mixing by pressing the mixing button. Once the injection is complete, remove the nozzle, clean it, and put it back on its support. Allow the dough to form for 1 minute, then open the cover. Using the plastic spatula provided, reincorporate any flour and dough adhering to the F register and to the corners of the kneading machine. You can repeat this operation 2 or 3 times. This step should take less than 1 minute. Close the cover and knead for 6 minutes. During this time, all the accessories required for extrusion.
This oil is added so that it does not stick to the
When
base
the mixing
plate.
stops after a total of 8 minutes, open the extrusion aperture by raising the F register and start extruding the dough test pieces. Remove the first centimeter of dough using a knife in a clean downward. When the strip of dough has reached sufficient length, cut it and place the piece of dough onto the laminating plate. Sheet the dough pieces using the roller 12 times. Using the cutter, cut the test piece and remove any surplus dough. Place the obtained patty on a resting plate. Transfer the dough piece to the resting chamber for 20 minutes.
This at a constant
Operation is
humidity
5 dough pieces in total.
for formation of the
You can
dough.
take benefit of resting time to clean the kneader. Remove the flange, the remaining dough, the blade and the F register. Immerse them into water and clean them carefully. Use a damp cloth to clean the mixing bowl. Once the mixer is clean and dry, you can start another test even if the first test is still ongoing. 28 minutes after the beginning of the kneading, the loading pad is displayed. Oil it and place the first dough piece on it. Put a drop of oil on the dough piece and press the Start Test button. The loading buffer moves the dough piece up to the plate and blocks it at the test station. Once the dough is in place and crushed, the pad is automatically removed and the device injects air into the dough while measuring the pressure in the bubble. The curve appears on the screen. The test ends when the bubble bursts, automatically detected by the device in real time. The plate loosens, and a squeegee unhooks the dough and drops it in the recovery tank. Repeat these operations on the 4 remaining dough pieces. Proceed by order of extrusion. The results are measured from the average of the 5 curves obtained. This is called an alveogram. If all tests are completed, you can clean the platine using a dry cloth, close the software, and switch off the device. I hope this demonstration was useful. For more information about our product, please visit us at www.kpmanalytics.com.
Hope you could understand something. Yes, no?
Yes, sir.
Any doubts? So basically, it's something like how you blow a balloon.